Hello and welcome to this session. Earlier we had seen several functions of the operating systems like the process management, the file management, the memory management, security, protection, and one among them is I/O, input output management, and the file management that is to be looked after by the operating system. So in this session we concentrate on the I/O and file management system handled by the operating system. So input and output devices are components that form the part of the computer system. So these devices are to be controlled by the operating system. So whenever the inputted devices like the keyboard, mouse, the sensors, the barcoders, etc. are there, they will send certain signals which needs to be understood by the understood by the operating system and should perform accordingly. So these signals we can consider them as some sort of commands that are being given to the operating system, and depending upon the command the operating system should function, or else the operating system should give the output. Like these commands received from the input devices instruct the operating system to perform certain tasks, or else it even controls its behavior also. So these are the two types of things that needs to be taken care by the operating system from the input devices. Suppose if you take the case of the output devices like the monitors, the printers and the speakers. So these are the devices that the operating system should instruct to. So this is a kind of reverse thing. Input devices will receive, the operating system will receive signals from the input devices, and the output devices should be given the signals by the operating system. So the output devices like the monitors, printers and speakers are the devices that receive commands and the information from the operating system. So when to give the output by the monitor or when to give the output by the printer, this should be controlled by the operating system. So then the operating system implements the abstract concept of the file by managing mass storage devices such as tapes and disks. So there are several devices which should be managed by the operating system. If you take for instance a floppy disk, or else a diskette, which is very much earlier used by the programmers, or else if you can see the hard disk that is there right now. So there are disks or diskettes in the various forms, various shapes with various mass storages. So these particular things should be coordinated by the operating system. So whenever we are thinking of various devices, then there should be one concept understood by the operating system, or else one particular thing, one particular entity that should be understood by the operating system, which is very much common to all these devices. So that particular abstract concept is nothing but a kind of a file. This is the concept introduced that needs to be understood by the operating system. Even though the information is stored on the hard disk, the information is stored on the disk, like the floppy disk, or the information is stored on the diskette, or the information is stored in any other means like a tape. The one and only thing that can be understood by the operating system is the file concept. So for this particular convenient use of the computer system, the operating system provides a uniform logical view. The physical existence of these particular things may be vary by other devices, but the logical view dragged or abstracted from them is the file concept, which is understood by the operating system. So these particular files are to be mapped by the operating system onto the physical devices. So this is the way how the operating system manages all these devices, whichever are having a different kinds of storage structures, a different kinds of sizes, a different kinds of architecture. Then let us look into the thing called as the file. This is nothing but you call a file related to the diskette, you call a file related to the hard disk, or you call a file related to the floppy diskette. The logical view derived by the operating system is one and the same. It is nothing but it is a collection of related information defined by its creator. So the commonly files represent the programs and the data, and these data may be varied, like it may be of numeric, it may be of alphanumeric, or it may be of completely alphabets only. So there may be some sort of free form files like the test files that are available, or some structured files like the database files that are available. So in general, what we can define is, it is nothing but it is a sequence of bits, bytes, lines or records whose meaning is defined by its creator and user. So these particular files ought to be managed by the operating system very efficiently. So the operating system should provide a name kind of thing for the identity reasons, and then it should be managed, and it should have certain size to be mentioned, or a certain name with some extension name that needs to be provided as per the data it contains, and even what type of information will it be containing, that is the extension name that should be provided. File management is one of the most visible services of the operating system. Like whenever you think of the files to be organized in certain way, so related files we group them and then we put it on to some directory in the Windows system. Or else if you take the case of a Unix operating system, it is completely a tree structured, inverted tree structures, wherein which completely the files are being organized as per the user or as per the information that it contains. So computer can store information in several different physical forms, among which it may be a magnetic tape, disk, drum, or other forms also. Each of these devices has their own characteristics and the physical organization. Suppose if you take the case of a physical diskette, it will have its own physical characteristics, it will have its own physical organization, it will have its own form, its own size. So this is very much differentiated with respect to some floppy disk or the magnetic tape. Then the operating system is responsible for the following activities in connection with the file management. As I told you earlier, file management is nothing but you may create a file, or else you may delete a file, you may name a file, or you may name a file with the extension name also, or else you may club some files and organize them in the form of a directory, or the support of primitives of manipulating the files in order to open a file, in order to then close a file after the editing is taken over, and then even you can delete a file, and then the mapping of the files onto some disk storage. Suppose if you are considering the disk storage as the hard disk, suppose that particular hard disk contents are being transferred to some sort of CD form, then that particular management is to be coordinated by the operating system. There may be some sort of backup also existing along with the physical existence of the files. So these particular things needs to be considered by the operating system, and these are the things comes under the file management operation by the operating system. So whenever we are talking of the I/O devices, the memory, the CPU, everything is having its own speed. Suppose if you take the case of these particular three only, then the speed of the CPU and the memory are very much high when compared to the I/O devices, because I/O devices, those are electromechanical devices. So those are being operated by some software or some hardware components. So whenever we are talking about the I/O, the speed associated with each and every I/O device is very much less when compared to the CPU speed and the memory speed. So in order to provide a kind of mismatching of the speed, there are several concepts introduced. The most significant problem in I/O system is the speed mismatch between I/O devices and the memory, and also with the processor. This is because I/O system involves both the hardware and the software support, and there is large variation in the nature of I/O devices. So there doesn't exist only one device, one I/O device. There are several devices. There are printers, there are monitors, there are CD drives, there are several things which are to be monitored, which are to be coordinated by the operating system. So they cannot compete with the speed of the processor and the memory. So in order to maintain the balance, between the speed mismatch, there are several concepts introduced, like the buffering concept is one. So a well-designed file management structure makes the file access quick and easily movable to a new machine. So a decently designed or a well-designed file management structure makes the file access quick and easily. It should seek the file, it should search the file, it should identify the file, whatever the file that the user is looking for, then it should predict, and then it may be transferred, or else it may be done as per the user requirements. Also, it facilitates sharing of files and protection of non-public files. Sharing in the sense, suppose if several users are using the same file, so the file should be saved. Like suppose one user may be allowed to edit the file or rewrite the file, and the other user may be allowed only write as per his privilege. So that particular thing should be taken care by the operating system. And then there may be some files wherein which even the public can also be viewed, which may not be allowed to edit, but which may be viewed. So there should be some sort of protection, some sort of security should be introduced by the operating system. So for security and privacy, file system may also provide some sort of encryption and decryption capabilities. This particular thing makes information accessible to the intended user only. So there should be some sort of protection mechanisms, like the password mechanism or some other mechanisms, wherein which only the user who intends to use should only be allowed to use. And then, as I told you before, as there is a speed mismatch concept between the I/O devices, the memory and the CPU utilization, there is a concept called as the buffering concept, and the buffering concept which relates to the I/O is called as the I/O buffering. That concept we please look into. A buffer is an intermediate memory area under operating system control that stores data in transit between two devices or between users, work area and the device. It allows computation to proceed in parallel with the I/O. So in order to balance this speed mismatch, suppose if the processor is there and then there is one I/O which is unable to compete with the CPU speed. So why I am saying you not competing with the CPU speed means we are allowing the CPU sitting idle until and unless I/O finishes its job and then it submits the thing to the processor. So there should be some sort of balance mechanism wherein which there lies one interface or intermediate memory which fetches all the things from the I/O, keeps it in the memory, which has been transferred to the CPU which is sitting idle. So in order to keep the CPU busy, there may be one buffer we can think of which immediately will be filling up by the I/O, so that the CPU execution will be running very smooth. Otherwise the CPU completely waits for the I/O to do its job. Then there are several kinds of situations wherein which the one method is called as the unbuffered solution. Unbuffered solution, this is the simple one wherein which the buffering is not there, like the I/O buffering is not there. Directly the user's work area information is being transferred from the hard disk by the OS. So there is nothing in between the user's work area and the operating system. This is a direct thing wherein which the OS will be taking care by fetching the data from the hard disk and throwing it to the user's work area. So I can show it through the figurative way. This is the simple one wherein which the OS is completely the interface which doesn't have any buffer memory, and then the information is taken from the disk and is being given to the user's work area. So this is a simple situation wherein which no buffer is there. Suppose if you take the case of single buffering. So sorry, in this case a single buffer transfer, blocks are first read into the memory or read into the buffer, and then move to the user's work area. So there is a simple stoppage wherein which we can think a main memory, or else we can think a memory wherein which we are thinking that particular memory as a kind of buffer with limited space, and we are taking in from the hard disk to that particular buffer and we are giving it to the user's work area. So this is nothing but whenever the transfer is taking place, it sits idle, and whenever the transfer is completed, it is filled up with a new material. So when the move is complete, the next block is read into the buffer and processed in parallel with the first block. Suppose if the CPU is handling the first block of memory, which is being given to the user's work area, then this particular buffer is being filled with the new block. So that is the thing happening, wherein which the CPU execution is also in parallel with the filling up of the block by the buffer. So this helps in minimizing speed mismatch between the devices and the processor. Whatever the processor that it requires is being given already, and the buffer is being filled up with a new block. And when it is completed, when the first block is completed, once again the second block is given to the CPU, and once again the buffer is filled with a third block. In this way, it can minimize the speed mismatch between the devices and the processor. And then this particular thing can be shown as this is the one. So here in this, a buffer is being introduced here. Whatever the information that the block is there, that is being first of all taken into the buffer, transferred to the user's work area, and processor will take care of the first block, and then whenever the processor is taking care of that particular information, then this particular buffer can be filled up with a new block. So there is a kind of parallel thing wherein which we can minimize the transition time. Then there is another thing called as the double buffering. Double buffering is nothing but we are putting two buffers here. Instead of one, we are just enhancing the single buffer situation with introducing another double buffer kind of thing, wherein which there are two buffers available over here, buffer A and buffer B. First of all, we fill the buffer A, and then buffer A and buffer B. Then it is being transferred to user's work area, and whenever user's work area is been transmitted by the buffer A and then buffer B, parallelly these two buffers are being once again filled up with new blocks and are being given to the CPU. So this doubles the buffer situation that is there in the single buffer. So these are the three situations available under the concept of I/O buffering. So coming to the disk organization, whenever we are talking about the disk, nowadays we are totally concentrating upon the hard disk only. No more we are using the diskette, or very rarely we are using the floppy disk, and very rarely we are using the magnetic tapes and all. So whenever we are just thinking of using of the hard disk itself. So how this particular hard disk is being organized? Let us see in this slide. These particular black surfaces are called as the flatters. The hard disk is nothing but it is the thing which consists of the disk, which consists of several minute disks. You can visualize, like there are several disks which are being clubbed together, or else which are being piled up like a flatters and are being organized. In here, this particular diagram, the black portions that are there is called are the simple disks, or else you can call that one those one are the flatters, and several flatters compiles one hard disk, compiles into one hard disk, and then they will be, and the middle portion is called as the spindle portion, upon which these particular disks are mounted, and for each and every flatter there are two surfaces available. So two read-write surfaces available, and with this particular head, like for each and every flatter, the head is available. Like suppose if you take the case of flatter 1, there are two heads available, one for the upper portion and one for the lower portion. Likewise, for all the flatters, there are several heads, and this particular black gauze one is called as the arm. This is electromechanical thing wherein which upon which these particular heads are being mounted, and the head positions are being totally controlled by the arm. So this flatter or else this individual disc consists of some tracks. So upon this particular things you can see some tracks, and then that particular whole disc surface is being divided into sectors. Suppose if you take the case of some identical some tracks upon the surface of this disc. Suppose if you see sector 0, sector 1, track 0, track 0 of flatter 1, track 0 of flatter 2, and track 0 of flatter 3. So these particular things forms a kind of cylinder, that is called as the various tracks of the identical tracks of various discs forms a kind of cylinder. And then for each and every disc, for each and every disc there will be certain sectors also. So the whole information will be stored on this disc whenever the address of the disc is given, whenever the address of the disc plus the track plus the sector is been given. Then only we can identify the information that we want to see. So the disc, there are various discs. The disc is a resource which is to be shared by various users. Suppose if I have one disc and that particular disc is been hard disk, and that particular disc is been shared by various users. So that particular disc forms a kind of resource wherein which it should be coordinated, or else it should be provided to various users, and the whole disc is to be managed. One user may be looking for one certain portion on the disk, and the other users may be looking for other portions on the disk. So that particular disk is to be managed by the operating system. So it is therefore has to be scheduled for use. So whenever I want to use and whenever the other users want to use, we can't give the thing at the same time. So that particular disk portion, like whenever I want some fixed portion needs to be referred, then I had to give one chance as per some sort of priority, as per some sort of queue that is to be maintained by the operating system. So there should be some sort of queue, or there should be some sort of scheduling policy which needs to be taken care by the operating system in order to provide the support to the various users when the disk when comes to the portion of the disk as a resource. So disks are the one providing lot of the secondary storage. So nowadays we are thinking for a even single user system, we are thinking of 128 GB of hard disk. So this is the way how we are thinking of the mass storage of the hard disk. As compared to the magnetic tapes, disks have very fast access time and disk bandwidth. Suppose if you want to take the case of a magnetic tape, it is a kind of sequential mode. Suppose if you want to access the information on the magnetic tape which is stored at the last, and we are thinking we are in the right now the head is at the starting position. So it should the whole head is to be the whole thing is to be transferred to the last position, and then only we can retrieve the information or we can access the information. But that is not with the case of the hard disk. In the hard disk we can randomly pick out the information, randomly we can get the information when compared to the magnetic tape. So the access time, the seek time is very much less when compared to the magnetic tape. The access time, whenever we are talking about the access time, it consists of two major components. One is the seek time and the other is the rotational time. Seek time is nothing but the time required for the disk arm to move the head to the cylinder with the desired sector. I told you the cylinder is nothing but the identical tracks on the same track number on various disks. You can see that same track number on various disks. Suppose if you have a disk, if you have disk 1, disk 2, disk 3 on the hard disk, then suppose if you are talking of track 0, track 0, track 0 of 3 various disks, then that particular track 0 forms a kind of cylinder on various disks. So it is that seek time is nothing but it is the time required for the disk arm, like the head that is to be moved to the cylinder on the desired sector. So that is called as the seek time. Then the rotational time is nothing but It is the time required for the disk to rotate the desired sector until it is under the read-write head. Already the arm is being moved in the seek time while we are thinking of the seek time. Rotational time is nothing but the disks are to be moved under the read-write head with a desired sector. That is called as the rotational time. The disk bandwidth is nothing but the total number of bytes transferred per unit time. Suppose if you are thinking some nanoseconds as unit time, so total number of bytes that are transferred are called as the disk bandwidth. So these are the three things that are associated whenever we are talking about the access time. Then we have various disk scheduling policies. A scheduling policy is nothing but it should attempt to maximize the throughput and also to minimize the mean response time. So whenever we are talking about the disk scheduling policy, suppose if several users are sitting and there is only one hard disk which is supporting all the users, so there will be some sort of queue. So that particular user requests are to be satisfied. Then in order to satisfy those particular user requests regarding the disk access, then there should be some sort of scheduled policy or scheduled mechanism or scheduled rule to be taken care by the operating system. So there are several algorithms that are available. Let us see the list. One is the FCFS, and this is the very simplest algorithm or simplest scheduling policy called as first come first serve. And there is another thing called as shortest seek time first, SSTF. And there is a third thing called as the scan scheduling. And under this scan scheduling there are two methods available. One is the C-scan scheduling and the other is look and C-look scheduling. Let us look into the FCFS by taking one example. This FCFS is the simplest scheduling policy wherein which the block of the cylinders have arrived and the queue is been given like 50, disk queue is given as 50 cylinder, then 91 cylinder, 150, and these are the sequence that is there in the queue already arrived. And then in the first come first scheduling policy, this has been given, the operating system is given the access with respect to the arrival of the disk queue. So the 50th, suppose if the head is at 50th position, then after this particular thing is fulfilled or satisfied, then this will move to the 91st cylinder, then 150 as the queue is growing into, like then it comes to 42, then 130, then 18th cylinder, likewise the whole thing has been satisfied. So this is nothing but it is fulfilling the request as per its arrival. So there are certain disadvantages included in this particular FCFS scheduling. Here look, first of all it is the start thing is at 50 cylinder, then it is moving to 150, and then once again it is coming back, 91 is touched and it is moving to 150, again it is returning back to 42. So there is the access time here requiring from 150 to 42 is greater. Suppose if you have the cylinder which is having here 130, that is not fulfilled and it is coming back to 42 and once again it is moving to 130, and there is huge wastage of the time over here in the FCFS scheduling. So then there is another scheduling policy called as SSTF, that is nothing but shortest seek time first. This particular policy, once again we take the same example as the disk as that is given in the first example. The this services all the requests close to the current head position. Suppose if the head position is lying at 50 and the nearest one, suppose if the head position is at 50 and among the available cylinders, which is the nearest one, 42 is the nearest one. So it will touch 42, like the head will go to the cylinder 42 and once again nearest to the 42 is 60. So it will touch 60, then 70, then 91, then 130, likewise it will move and last it moves to the 18 position. So in this way it fulfills a request. So here what it is looking is, it is first of all starting at one position and nearest to that particular position which is the cylinder available. So that particular thing is taken into picture, into consideration, then it is moving, the head is moving to that particular cylinder position, then moving to the next available situation, next current head position is moving to the next nearest request. Likewise the whole things are being satisfied. But there is another thing called as the scan scheduling policy available. In the scan scheduling policy, what it thinks is the disk arm starts at one end of the disk and serves all the requests in its way towards the other end until it reaches the other end of the disk where the head movement is reversed and continues servicing in the reverse direction. This is nothing but it is not scanning the next available, next nearest position. What it is doing is, it is looking for the next nearest position, but the side also is being considered. Suppose if the head is moving to left side, then all the left side requests are being considered, nearest left side requests are being considered, and then once it touches the extreme left, then once again it goes back by touching all the next right side requests. Like here in the example, the disk, the position, head position is at 50, and then the nearest scan cylinder is at 42, it touches 42, then moves in the extreme left. Like now we are considering only the left movement. So it is going to 18, then it is coming to 0th position, and once again when it reaches to the extreme left, then it moves to the total right by servicing all the requests of the scheduling. So this is the way how the scan scheduling works. Then there is another scheduling under this scan scheduling, and this is a kind of specialization called as the C-scan scheduling. C-scan scheduling is nothing but it differs only at one instance. Like whenever it is, the C-scan also moves head from one end to the other end as like that of the scan scheduling, but there is the difference here is that after the head position reaches the end, it immediately returns to the beginning and skipping all the requests on the return trip. So the servicing of the request is done along one path only. Suppose if you take the case of scan scheduling, suppose if it is moving to right, all the requests of the right are being fulfilled. Once again, it won't satisfy the request while it is coming back. That is the only difference between the scan scheduling and the C-scan scheduling. What it does is, when it moves extreme right, once again it leaves the total jobs there, then and there itself, and then it comes to the extreme left, once again it processes the request. So this is called as the C-scan scheduling policy. And then whenever we are thinking of the disk, the hard disk as the mass storage media, so it is having a very great disadvantage. That is nothing but it has very high failure rates. Because the speed, whenever we are considering the speed, whenever we are considering the access, and whenever we are considering about the other things, so whenever these disks are moving in a high speeds and all, there may be a chance of high failure rates. So the disks have high failure rates, and hence there is a risk of loss of data and lots of downtime for restoring and disk replacement. So to improve this particular disk usage, many techniques have been implemented. So one of the technique that I am talking about is the redundant array of indispensable disks. Its organization is based on disk striping or interleaving, which uses a group of disks as one storage unit. So whatever the disk that we are using, so there will be one kind of mirroring strategy followed. So whatever that we are, suppose if this is nothing but the duplicating thing of the information. Like if at all we have one hard disk, then the same kind of hard disk we are visualizing, and that particular thing is maintaining the backup. So once the hard disk fails, so immediately the disk, the RAID technology helps us to retrieve the information from the disk that is maintained auxiliary to the disk that is available. So this is the advantage that we are getting from the RAID technology. So whenever we are talking about the disk, so there should be some sort of, whenever we are accessing some information on the disk, So suppose if that particular information is being accessed from time to time, the same information is accessed from time to time. So it may be some sort of wastage of time also. Like suppose if I am accessing some cylinder, 50th cylinder had the information under the 50th cylinder, and the head position should be at 50. So suppose if that particular position's information is being used very frequently, quite frequently, and accessing that particular information very often may be very much inconvenient, and it may be of wastage of time. So some sort of caching, some sort of buffer is maintained on the memory, wherein which whatever the information that we are recently used are being preserved for some time, and then whenever we are trying to access that information, first of all it visits the cache space, it looks into if the information is available, then it will take the information from there, otherwise only it will go to the disk and brings the information. So let us see in the slide. Disk caching is an extension of buffering. Buffering means we are just thinking of only certain space, but caching is nothing but we are keeping the buffer, but the buffer consists of the information whatever that is retrieved very recently. So it is derived from a French word called cacher. In this context, a cache is a collection of blocks that logically belong onto the disk but are kept in memory for performance reasons. It is used in multi-programming environment or in disk file servers which maintain a separate section of main memory called disk cache. The basic advantage that we are getting from the disk cache is these are the set of buffers that contain the blocks that are recently used. Please underline the word recently used. So this is nothing but the buffer is the buffer that we are talking about. The cache that we are talking about consists of the information which is very much recently used. The cached buffers in memory are copies of the disk blocks, and if any data here is modified, only its local copy is updated. So to maintain integrity, updated blocks must be transferred back to the disk. Caching is based on the assumption that most shortly accessed blocks are likely to be accessed again soon. So whenever we are talking about the frequently used, whenever we are talking about the accessing mechanism, the information may be accessed for viewing purpose or else for the updating purpose also. Whenever we are talking about the updating purpose, suppose if we are updating the information that is available at the cache, which is the very much local copy to the memory, we are not totally trying to update the information at the hard disk. So there should be one mechanism wherein which whenever we update the very recently used information, that should be transported or that should be thrown to the hard disk also with the same updation. Then let us see how these particular things are being managed by the OS manager. We have certain requirements. We have seen the various disk scheduling policy. We have seen various users requests. We have seen various things that the operating system should be considered with respect to the disk management. So there is certain view by the operating system in order to manage all these things with respect to the files. So the files are mapped by the operating system onto physical devices. Many factors are considered for file management by the operating system, like the directory structure, the disk scheduling and management, file related system services, and the input output. So these are primarily the categorization that we are looking for, by the operating system in order to manage the files. Most operating systems take a different approach to store the information. There are three commonly file organizations. One is the byte sequence, the other is record sequence, the other is the tree of disk blocks. So there are three kinds of file organizations, wherein which in Unix this is a simple byte sequence form, and suppose if you take the record sequence, the arbitrary records can be read or write, but a record cannot be inserted or deleted in the middle of a file. So CP/M works according to this particular. CP/M is the operating system wherein which this particular thing is been implemented. And then if you take the case of the mainframes, then the tree organization is followed. Like you can insert the record, you can delete the record, you can insert the file, you can delete the file, and n-keyed in records may be inserted, a new record can be created. These kinds of things are followed. So these are the three kinds of file organizations we are talking about. Then let us see these particular files. Whenever we are talking about the files are being organized in certain directories also. Suppose if I am managing the enrollments of the students for year 2007. So I may be looking a directory, I may be creating a directory wherein which I may be taking various files for different kinds of programs and their enrollments. So I may be categorizing those particular enrollment files and I may be putting them in a separate directory under 2007. Suppose if I want to take the data like for the next year, then also I create one directory in the name of 2008 and I preserve the files over there. So there is a kind of organized behavior, organized way of keeping the files on the hard disk. So let us see, there are various ways under which we can organize them. First of all, view one of the types called as the single level directory. In the single level directory, it is nothing but it doesn't have any kind of various levels. It will have only one level wherein which we have to store the file. So ABC is a file, test is a file, XYZ is a file, and each and everything under one directory we are trying to preserve the file. So what is the disadvantage with this particular system? This is nothing but, suppose if you want to create a file, you have to create it with a unique identification. As all the files whatever we are thinking lies under the single level, at the same level. So it should have the various names for each and every file. Suppose if the file has the same name, suppose if you are creating a file which has the same name or identical name that is there already existing in the directory, then this particular information is been overwritten. So that is the basic disadvantage with the single level structure. Then comes the two level directory. Two level directory is nothing but for each and every user there will be a certain directory, and this is a very good system wherein which for each and every user you have a separate directory, and under that particular directory the user can store his or her files. And there is another directory called as the tree structured directory. The tree structured directory under this, but this is a very good system followed by the Unix operating system, and under this particular tree structured algorithm, the main files, the operating system files will stay at the root directory, and then under various directories the other files will be stored. So it can have the root, this is called as the root. Under root you have three separate directories, and then under that particular directories you may have other subdirectories or else even the files also. In this way the whole tree structure, the whole files are being organized. Then you have another directory structure called as the acyclic graph structure. This is nothing but suppose if there are several users who wants to update a single file, or else if there is a shareable file wherein which it needs to be updated by various users. So in that particular instance we can think of acyclic graph directory. So once that particular file is been opened, updated, then other user may be restricted, or else that particular copy should be stored and then it should be given to the other user also. So in this particular acyclic graph, there won't be any cycles. There won't be any cycle kind of thing. If once that particular cycle is formed, that particular thing is called as the cyclic directory. This is the general graph directory. In the general graph directory, the difference between the acyclic graph directory and the general graph directory is nothing but in the general graph directory you may have cycles, but in the acyclic graph directory it won't allow the cycles. So before concluding this particular session, let us summarize the points that we had learned in today's session. Here first of all we had identified the requirement for the disk to be managed, like the IOs are to be managed by the operating system, disks are to be managed by the operating system, various disk policies, disk scheduling policies we had looked into, and various structures, physical formational structures that we had seen. So with this I hope that you had understood the things today, and in the next session I will be taking the topic called as the security and protection that is to be handled by the operating system. Thank you.